Sathyabama Institute of Science and Technology.
Myself, Bhanu from CSE Department, Assistant Professor, Sathyabama Institute of Science and Technology. In today's video, we are going to take a topic of entity relationship model under DBMS. Entity relationship model. Before we moving on to entity relationship model, I am going to tell about what is DBMS. DBMS is nothing but a DBMS which is used to manage a data, retrieve a data, and the data, if we need to update any data, we are using a database management system. ER model, which is a conceptual model for designing a database. It is also known as a blueprint of a database. ER model, which represents the logical structure of a database. It includes the topics like entity, attributes, relationship. These are all entity, attribute and relationship which is used to build a logical structure of a database model. We'll see one by one what is entity, what is attribute and what is relationship under each and every slide. First one is symbols used in ER model. What are the various symbols which are used to build a ER model, entity relationship model? The various symbols are rectangle which represents the entities. Attributes are represented by using a eclipse symbol. The relationship between the entities and attributes are done using a diamond symbol. Then the connection to make between the relationship, attributes and entities are done using a line symbol. Multi-valued attributes are represented using a double eclipse symbol. Then weak entity are represented using a double rectangle. First one, entity. Entity is nothing but a real world object. Real world object is nothing but if we take a college database, if we want to store a data about a college database, the various entities which we are going to use is example, a staff details, teaching staff, non-teaching staff, student database. These are all the entities which we are using under a entity. The real world object or a concept based anything comes under a entity. For example, in college database, student, teachers, classes and courses are the various entities which we are using to store a data in a database. Entities are represented using a rectangle symbol. Each and every entities must hold their properties. Properties are nothing but attributes which we are going to see in the next upcoming slide. For example, here student is an entity. Under a student entity, we need to update various attributes which is used to store a data about a student. For teachers, we are going to use various attributes which store a data about a teacher. Then likewise project also. Attributes. Attributes are nothing but it is the properties which are used to represent the entities. Attributes which is nothing but the properties. There are various attributes which are used under each and every entity. For example, if we take entity student, the attributes which define the entity student is name, student ID, student phone number, student address. These are all the various attributes which define the entity of a student. Various types of attributes are there. First one is a simple attribute. Simple attributes are nothing but which holds only atomic values. Atomic values are nothing but the values which cannot be further divided or which cannot be divided into two or more level comes under a simple attribute. For example, if we take a age cannot be divided further. If we take a person's weight, the weight also cannot be divided further. If we take a phone number which holds only a 10 digits, there is no phone number which holds more than 10 digits or the digit which cannot be divided further, that comes under the atomic value. So first one is simple attributes. Simple attributes are attributes which holds only atomic values that cannot be divided further, that comes under the simple attribute. If we take a student, the various simple attributes are weight, age, then phone number, that comes under the simple attribute. The next one is composite attribute. Composite attributes are attributes that is made up of more than one simple attributes. For example, if we take a name, the attribute name which can be further divided into first name, last name. So if any attribute that can be further divided into two or more attributes, that comes under a composite attributes. Composite attributes are further divided into two or more attributes which looks like a tree-like structure. Here the name has been further divided into two furthermore attributes which is the first name and the last name. Next one is single value attribute. Single value attribute which contain only a single value. For example, if we consider a person can hold only one PAN number, one Aadhaar number, one voter ID. So there is no person which holds more than one PAN number or one Aadhaar number, that comes under the single value attribute. So single value attribute which contain only a single value, that comes under the single value attribute. Next one is multi-value attribute. For example, if a person can hold more than one phone number, can hold more than one email address, that comes under a multi-value attributes. So multi-value attributes are nothing but attribute which holds more than one value that comes under a multi-valued attribute. For example, phone number, email address, etc. So multi-valued attributes are depicted by the symbol of double ellipse. For example, phone number. For a entity student, phone number is an attribute which contains multiple values, so it is considered as a multi-value attribute which is declared by the symbol of double ellipse. The next one is derived attributes. Derived attributes are attributes which is derived from some other attribute is considered as a derived attribute. For example, if we consider a person's age, we can calculate the person's age from the date of birth, year of a birth. So here any attribute which is derived from other attributes is considered as a derived attribute. Here under a student entity, if we consider a age is derived from the birthday date. So from the birthday date we can calculate the age of a person. So the age is considered as a derived attribute. Derived attributes are denoted by the symbol of dashed ellipse, like this. Like this dashed ellipse we have to denote the derived attributes. The next one is entity set. So far we have seen about what is an entity, what is an attribute. Now we are moving on to our next topic, which is an entity set. Entity set is nothing but a group of similar entities or an entity which shares the similar attribute values that comes under the entity set. For example, if we consider a student in a college database, if we consider a student, if we consider a teachers, student holds the same attribute values, teachers holds the same attribute values. For example, any student, if we take, they holds the most of the attribute values are student ID, student name, then student address, student phone number, student GPS. These are all comes under the same attributes. Under the same attributes we can store different data. So any entities which shares the same attribute values that comes under the entity set. So a collection of similar type of entities is said to be a entity set. Next one is relationship. So a relationship is nothing but which represents the association between the entities, different entities. For example, if we take two entities, student, course. Student is a separate entity, course is a separate entity. If we need to make a relationship between a student entity and a course entity, we need to make a relationship that is enrolled. Student enrolled in a course. So the connection between a student and a course is made by the relationship enrolled in. So enrolled in is a relationship which connects the two different entities, that comes under the relationship. So enrolled in is a relationship. If we need to declare any relationship between the entities, we need to declare it inside a symbol, diamond symbol. So diamond symbol which represents the relationship between the entities. The next one is degree of a relationship. Degree of a relationship is nothing but once we have chosen the relationship entity and the various attribute, we need to calculate the degree between the relationship. Degree of relationship is number of different set of entities participating in a relationship. In a relationship, how many different set of entities are participating? To calculate that, we need a degree of a relationship. To calculate the degree of a relationship, there are four types of degrees. First one is unary relationship. If only one entity participating in the entire network, that comes under a unary relationship. Here, married, person married to a person. Person is an entity, married to is a relationship. Person can hold different attributes. For example, person ID, person name, person phone number. Under a person entity, we can store n number of persons, but a person can be married to only a single person. So here, person is the only entity which takes place in a part of a relationship, that comes under the unary relationship. Second one is a binary. If two different entities participating in a relationship, that comes under a binary. Here, student, course. These are the two entities which participating in a relationship under the enrolled in. So enrolled in is the relationship here. Student enrolled in a course. Only two entities are participating in a relationship, that comes under a binary relationship. Second one is ternary. If we take three entities in a relationship, for example, student, teacher, course. Three different entities are there. Student takes a course, teacher takes a course. Teacher teaches the course to the student. So three entities are participating in a relationship, that comes under a ternary relationship. If more than three number of entities are participating in a relationship, that is said to be a n-ary relationship. Next one is types of relationship. Under types of relationship, we need to calculate one-to-one, whether it is comes under any one of the relationship type. First one is one-to-one. One-to-one is nothing but how many instances coming under a relationship. For example, surgeon headed by HOD. Surgeon, HOD, these both are the entities here. Headed by is the relationship. A department contains one surgeon, one HOD. If one instance comes under a surgeon, one HOD comes under a department. So one instance that comes under each and every entity, that is said to be a one-to-one. When only one instance of an entity is associated in the relationship, that is marked as one. So surgeon headed by HOD or a department headed by HOD. A department is a single department. CSE is a single department. HOD, for each and every department only one HOD will be there. So each department one HOD will be there. So 1:1. So it comes under a one-to-one relationship. The next one is one-to-many. If one entity holds only one instance, other entity holds n number of instances, that comes under a one-to-many. When more than one instance of an entity is associated in a relationship, that comes under one-to-many. Here a department has doctors. One department has n number of doctors. So 1:n number of doctors. Department is one department, doctors. In a department we can have n number of doctors. So department has doctors. 1:n, one-to-many relationship. This is next one is many-to-one. If same, it is like a 1:n is previous one. Next one is many-to-one is the third one. More than one instance of an entity is associated with one instance of an entity, na, that comes under a many-to-one. Here multiple surgeries done by a single surgeon. Single surgeon can do multiple n number of surgeries, or a single student can do n number of projects, that comes under a many-to-one. Multiple surgeries is many instances, so it is considered as M. Surgeon, single surgeon is a one person, so it is considered as a 1. So multiple surgeries done by a single surgeon, which is many-to-one relationship. Next one is many-to-many. Many instance to a many instance, that comes under a many-to-many relationship. Employees works on multiple projects. N number of employees can works on n number of multiple projects, na, that comes under a many-to-many relationship. Next one, this is a sample diagram for a ER diagram. To draw a ER diagram, first we need to analyze what are all the various entities we needed, then what are all the various attributes for each and every entity we needed, then what is the relationship between these entities, then we need to analyze the relationship among them. Here I have taken a student database. Under student database, I have considered the various entities: student, class, exam. These are the entities that I have taken under a sample student database. So a relationship between a student entity and a class entity is student takes a class. Then class with the exam. Class has exam. So that is the relationship between the class and the exam. Now I need to define the attributes for each and every entity. For a student, I can consider the various attributes are student ID, name, GPA, clubs, honors. These are all various things. From the name, we can have two furthermore composite attributes: first name, last name. Then has honors. The composite attributes as honors is derived from some other attribute, so it is considered as a derived attribute. Then for class, I have taken only class ID, A class or B class or whatever the section is, so it is considered as only one attribute. Exam, for exam I need to take exam ID, subjects, anything I can take. So comes under exam entity, we can take an exam ID. So now I need to mark the relationship student class. In a class, n number of students are there, so it is a many relationship. Many, then in a department or a school has n number of classes, so it is also taken as a n. So many to many relationship. This is how we need to draw a sample ER diagram. Thank you.